Just like we did with the exponent rules, we're going to go from the yellow foldable to the white practice sheet, and we'll just keep going back and forth, okay?
Okay.
Just make sure that you are on the radical rules side. All right? All right, so up at the top, rational exponents rule. All right? So you're familiar with this. If you have the rth root of x to the p power, this is the same as saying x to the power over root power. All right, so we have two examples here. All right, so for example 1, you have the the square root of 3 cubed, right? This is the same as saying 3 to the 3 halves power. Yeah? All right. So then example 2. The fourth root of x to the 7th power. How would you rewrite this?
X is 7 divided by 4.
Yeah, x to the 7 over 4 power. All right. So let's go to our white practice sheet. Okay. And then we have the fourth root of 25 squared. Yeah? Okay. So let's rewrite this. This is going to be 25 to the what? 2/4 power. But we can't leave it as 2/4. You can simplify this, so it's going to be 1/2. So this is 25 to the 1/2 power, which equals 5. Yep. All right. 25 to the 1/2 power, that's the same as saying what? Square root of 25, which is 5. Okay? Louise, you okay with that? All right. Let's look at the next example. So we have 10 over, all right, 125 to the negative 1/3 power, right? Okay. So, you know what? I don't like this negative exponent. So how do I make this 125 with a negative exponent? How do I turn that into a positive? Yeah, you have to move this up. So up on top now we have the 10, right, which stays there. And then we have to move this guy up. So 125, and now it becomes positive 1/3 power. Yes? Yeah, that's a negative. I'll fix that next year.
It's like no.
I know, because it like, yeah.
Like on my paper.
Probably fix that. All right. So then there's nothing in the well, there's a 1 in the denominator, right? So really, I don't need to have this fraction bar anymore. But what is this? What is 125 to the 1/3 power? That's the cube root of 125, which is what? 5. So now we have 10 times 5, which equals 50. Okay? Are we okay with this? All right. All right, so then let's look at the radical addition rule. All right. So with this, okay. All right, there are a couple things that you need to remember with this, okay? So your roots have to be the same. All right? Those roots have to be the same for you to add, okay? And your radicands have to be the same. The stuff inside the radical, they have to be the same.
So both situations happen.
Yeah.
Same time.
So what you're really doing is you're really just adding your A and B together. Okay? You're just adding those outside things together.
The other thing was inside.
Yes, and those other ones should be the same. If they're not the same, then you can't add those together. Okay? So you can only add A plus B from like the same R, same root, and the same X. Okay? And you don't add these together, it just comes over. So A plus B times the Rth root of X. Okay? It'll make a little bit more sense when you see numbers or variables with it. So let's try example 1. All right, so our easier one. So if I gave you three root x plus 2 root x. Yeah. Look at that. Do they have the same root? Yes. Do they have the same radicand, like the stuff inside the radical? Yeah. So then this means you just add these outside numbers together, and then that's 5 root x here. Okay? So here's example 2. We have 2 times the 5th root of 7, 6 times the 5th root of 7. What do we get? Good. All right, so let's go to our white sheet again. Practice. So, yeah, if I look at this, okay, Isaiah said they're not the same. Well, you know what? Your roots are the same, okay? So it has potential to be the same. But right now, inside the radical, they're not the same, right? So if it's not, all right, well, let's see if we can simplify. The 4th root of 3x. 3 and x. Can I get a group of 4 of anything in here? No, so this one is okay. I'm going to leave that for now. Let's look at this one on the left. I have 1, 3, but how many x's do I have? 5. That means 1, 2, 3, 4, 5. Look at that. I have one group of 4 that can come out, yeah? So let's simplify this. So the 5 was already out. Let's see. I'm going to leave some room. One of these x's can come out, yeah? And then inside, I still have the 3, and I have this 1 x that's left over. Yeah. Okay? And then plus x is the 4th root of 3x. So now it's the same, yes. Okay? So then now we can add the outside. Alright? So if I have 5x plus 1x, what is that? Huh? 6x. Yeah. 6x. And then don't forget to bring your, the common rth root. What is this? 3x. Sorry. There you go. Okay? Are we okay with this? All right, let's try the next one.
Yeah.
Okay. Oh, they have the same root, but is the stuff inside the radical the same? No, but you can simplify, right? So the 3 and the 3 are the same. All right, let's see which one we need to look at. Cube root of 2, well, the 2 is already a prime number, so that one's good. I need to simplify this one, right? 16. So let's see, cube root of 16. 16 is 4 times 4, right? But the 4 I can break down even more, 2, 2. So then this is cube root of 2 times 2, and then 2 times 2. Yes? How many do I need in the group? 3. So there we go. So that means I have a 2 that can come out. I have a 2 that needs to stay in. Yeah, I mean, I just simplify the radical, right? And then plus my second one, which is 5 cube root 2. So guys, now can I add them? Yes, because these guys are the same. So now it's good, 7 cube root 2. Okay? All right. Now let's talk about the radical subtraction rule. Okay? If you need me to slow down or go back, just let me know. Okay?
Yeah, can you go back real quickly?
Yeah.
Just for-
What did you not get? But you're not writing anything down. What do you need? Oh. Leah, why don't you say something? All right. So the subtraction, right? So the subtraction rule is the same as addition, okay? Your root has to be the same, and then the stuff inside the radical has to be the same. But this time you're not doing a plus b. What are you doing?
A minus B.
Yeah, a minus b. Because it's subtraction, right? So let's talk about our first example. Easier ones, right? What is 3 root x minus 2 root x? 1 root x or just root x? Hmm? All right, so example 2. All right, cube root of 16 minus the cube root of 2. Okay. Delete this. Get this out of the way. All right. Okay. Yeah, because cube root of 16 is 2, 2, 2, 2. We just did this, right? 2 cube root 2, right? 2 cube root 2 minus cube root 2. All right, because there's a 1 there. 2 minus 1 is 1. All right, and then cube root 2. Okay?
But the stuff inside stuff is the same, right? Like
Yeah.
the radical and the cube or whatever that's outside.
Yeah, no, they should stay the same. If after you simplified it, if it still doesn't match, then you can't subtract them. and it's just
Or
what
you
it
did
is.
wrong.
I mean, if you did it right and they don't
Oh,
match.
yeah.
Yeah, if you did it wrong, then you're just doing it wrong. But all right, let's look at this. Negative 2 root 8 minus root 50. Okay, so with this, all right, they're both square root, but 8 and 50, not the same. In fact, 8 and 50, they're both not prime numbers, so maybe instead of just simplifying one, I could simplify both, right? So 8. All right, let's see. 8. 8 is what? I can do this over on the side here.
Well, can you do
Square
it
root of 8.
Can you
Mm-hmm.
do it differently?
Which one?
The way where you go like 8 and then 2 and then 4 and then 5 through ladder, go back. Is that way? I don't know that.
All I'm doing is just breaking it down. 4 is just, okay, so I'll do the factor ladder for the 50.
Okay.
All right, so if I break down 8, I get 2 times 2 times 2, which gives me 8, and that's all inside, right? How many do I need in the group to come out? 2.
And then 2 stays.
So one of them comes out, and that one stays in, yeah? Okay, so if I bring it back over here, you know, I already have this negative 2 that's outside, so I need to multiply it with the one that came out.
Yeah.
Does that make sense? So negative 2 times 2 root 2, which gives me negative 4 root 2. All right, so this one's done. Now subtract. Okay, let's do square root of 50. All right, so 50, if you do the factor ladder, 2, 25, 5, 5, 5, and 1. You have a pair of 5s. So then it's 5 root 2. I don't have anything on the outside that I need to multiply to the 5, so I'm just going to bring it over. 5 root 2. Okay? So now, can I just subtract A and B?
Yes.
Yeah, because they're both root 2, right? What is this? What's negative 4 minus 5? Questions about this?
It's okay to have negative.
Yeah, because it's a negative.
Oh, okay.
Yeah, why? No, negatives aren't bad.
And this, yeah.
All right, let's try this one. So we have 12 to the 1/2 power minus 27 to the 1/2 power. This one you can subtract because they both have a root of what? 2, right? Yeah, because the 1/2 means square root. So you know what? I don't really like the way it's written. I'm going to rewrite this. Square root 12. 12 has a power of 1, so I'm not going to write the 1, right? Minus square root 27. Yeah? Can I subtract it just the way it is? No. Simplify both of them, please. You guys do that. So for this, you should have 2 root 3 minus 3 root 3. Yes? Okay. If you don't have this, let me know. All right, so subtracting. What is 2 minus 3?
Negative 1.
Yeah. So you could say negative root 3. If you wrote negative 1 root 3, that's fine. You're not going to get it wrong. Okay? But just know that, you know, you probably won't see the 1 there. Okay? All right, questions about this? Okay. Now let's talk about multiplying. All right? So with multiplying, okay, okay, so with multiplying, here's the rule, and I'll tell you a couple of things that I think help, Okay?
Okay.
What you do is you're going to multiply A and B. Alright? So just like the adding and subtracting, they need to have the same root. Okay? But unlike the adding and subtracting, you can have different stuff inside the radical and still multiply. Alright? So you can have A times B.
The A and B.
Yeah, they're different, right? Because you're just multiplying. It's just like when you did the adding and subtracting, they could be different. All right, and then inside your x times y, you can multiply. So with these, when you're multiplying radicals, the only thing that needs to be the same is the root. Okay? All right, so a couple of things here that I think would help.
I have a question.
What is your question?
So you multiply A and B, you get x, and then you multiply the two what's inside both of the radicals, and you get the number. And then the roots have to be the same, so they stay the same. Is that what you're saying? Okay.
So basically the rule is inside stuff multiply each other. Inside times inside. Okay? Inside meaning inside the radical. Outside meaning outside the radical multiply each other. Does that make sense? You can't go outside times the inside. You can't do that. Outside times outside, inside times inside. Okay? And just as a rule of thumb, you know what? Simplify your radicals first if you can. Because then that'll make your numbers smaller and it'll make it a little bit easier. Okay? Because you don't want to multiply inside numbers and then get this humongous number that you're trying to do a factor ladder for. You know what I mean? Take up the whole page. Okay? So let's look at some examples here. So example 1. So if we have the fourth root of 2 times the fourth root of 8. Okay? All right, can I simplify any of these? 2 is just 2. I can't get a group of 4 here, right? And then 8 is 2, 2, 2. I don't have enough 2's to make a group of 4, right? So I can't simplify it first, so I'm just going to multiply. Outside, well, outside is just 1, right? I don't have anything outside. So I have inside and inside. What's 8 times 2? 16. Okay? So now I have the fourth root of 16. Can I simplify this? Yes. Because 16, 2, 8, 2, 4, 2, 2, 2, right? Then look at that, I have a group of 4 2's. So then this is really 2. Okay? So if you can simplify first, do it, and then multiply, and then simplify. But if you can't simplify, just multiply and then simplify. All right, let's try another example. Oh no, not negative 3, sorry. Okay, square root of 3 times the square root of negative 6. All right, let's try this one. Okay, so square root of 3. Well, 3 is a prime number. I can't break that down, right? That is what it is. Square root of 3 times, wait a minute, square root of a negative number. What does that turn into? Good. So I root 6. Yeah? All right. So 6, I can think about it, and 6 is 3 times 2. I'm not going to have a group of 2 of the same that I can take out, right? So let's just multiply, okay? So outside times outside. Well, on the outside, I just have my I, right? Inside was 3 times 6. 18. Right? So I have I root 18. But guys, do I stop here? No. Yeah, you got to simplify it down because 18 is too big of a number for you to just leave, right? So 18, if I break this down, that's 2, 9, 3, 3, right? So I have a group of 2 3s. So one of those comes out. What was already out? I. And then root 2. The 2 has to go back in. Okay? Why? How else would you write it? I mean, you can. Just be careful. If you put this I over here on the end, just make sure you don't stick it right back in with the radical. Because if you do, then it's wrong. Because it came out. Right? So if you're going to put the I back here, just make sure it is clearly behind the radical. Okay? But you'll, more than likely, you'll see it written this way. Like on the SOLs and stuff too, it'll probably be written this way. Okay? Alright, so let's look at this next example on the white sheet. Okay, so we have outside and inside. You know, we could just multiply everything, but, you know, I like simplifying before multiplying. What do you guys want to do? You want to multiply first and then simplify?
Simplify.
Alright, yeah, let's simplify first. Okay. So we're looking for groups of 2. You know, just to scan it. If I look at the first one, look at that. I have 2 y's. I can simplify that, right? Look at the second one, square root of 4. That one. Okay. Alright. So if I take the square root of 3xy squared, okay? I'm just going to simplify the radical, right? The 3. 3 is a prime number, so that stays in, yeah? How about this x? How many x's do I have? Just the 1, so it can't come out. How about the y's? How many y's? 2. So if I have 2 y's and I need a group of 2, well then that comes out, right?
Yeah.
Okay. So then I'm going to bring this over and I'm going to multiply it with whatever was already out, negative 4x. Does that make sense? Okay. So I have negative 4x, bring over that y, and now this is root 3x. Okay? And then times, well, let's do this one. Square root 4xy b to the 4th. Right? I'm just simplifying my radical. So, square root of 4, what is it? 2. What about this x? I only have the 1, so it can't come out. So that one has to stay in. How about the y? How about z? Good. Okay? So that I'm going to bring over, and I already had a 2 out here. So I need to combine it with that 2, multiply it, right? So 2 times 2. Oh no, I should have used a different color. Okay. 2 times 2, z squared, square root xy. Yeah? Okay. Alright, so I'm going to clean this up a little bit. I have negative 4xy root 3x times 2 times 2, which is 4, z squared root xy. Yeah? Okay, so I simplified, and now I'm going to multiply. Okay? So then multiplying means you're multiplying outside times outside and then inside times inside. Yeah? So outside. Negative 4 times 4 gives me what? Negative 16. X, Y, Z squared. Yeah? Okay. And then inside, what do I have? 3 x squared y. Okay? So we did simplify, we did multiply, now we have to simplify. Okay? You always have to simplify again. Alright, so the only thing that you can take out is just that, right? Because the 3, you don't, it's just 3 times 1. Y, you only have 1 y, but you have 2 x's. So this is going to be, x comes out, I'll just put that up here, okay? Negative 16, now we have 2 x's, so x squared, y, z squared, root 3y. Now we're done. Okay? Hmm? Oh yeah, I mean it'll get progressively a little bit more challenging. Hmm? You know what it is? It's you have to make sure that you take your time. Okay? Don't skip anything unless you're like 200% sure, because it's really easy to make mistakes. All right? Because I could skip around, but I'm not. I'm doing it the long way so you guys can see the actual process here. All right? All right. Let's try this one. So this next problem, there was a problem like this that was on the SOLs like 3 years ago. Everybody in Fairfax County got it wrong, basically. Okay? And it was just a weird problem for everyone apparently. So I just want to make sure that we understand how to do something like this, okay? So with this, you might look at this and go, you know what, I'm going to multiply first, and I'm going to do inside times inside. Okay, wrong. If you do inside times inside, what does that do? What's a negative 5 times a negative 125? Positive 625, right? You just changed the problem, okay? That's why. Make sure you simplify, okay? If you have a negative inside a square root, what comes out? Yeah. So this is I root 5 times, good, 5I root 5. Okay, good. All right. Are we okay with where I got 5I root 5? Factor ladder. All right. So now if we multiply the outsides and we multiply the inside, well, we get 5I squared root 25. I think that's why everyone got it wrong. I think they just went straight to multiplying and they multiplied the inside and they turned it into a positive number. So we can't do that. Okay. What is it? Square root of 25 is what? 5. So then this turns into 5. We already had a 5 and we had an I squared. What's 5 times 5? 25. And what's I squared? Negative 1. So this turns into a negative 25. And please make a note for yourself. I squared equals negative 1. Isaiah, stop. Commentary. Okay? All right. All right, now let's talk about division, radical division. Okay? Alright, so if you have a fraction inside a radical, okay, and we've talked about this before. I know you guys hate when you see a fraction inside a radical, but, I mean, it just means the same thing as saying the rth root of your numerator divided by the rth root of your denominator. You can split it up, okay? And if they're already split up, you can always join them back together. All right? Okay, so example 1, square root of 4/9. Okay? I feel like you guys will look at this and go, oh, no solution. Something silly, right? Split it up. So it's square root of 4 divided by square root of 9. What's the square root of 4? 2. What's the square root of 9? So this is just 2/3. Okay? So then this one is your example 2. You have the square root of x cubed over 400. So I can't simplify this fraction, right? So I'm going to split it up. Square root of x cubed over the square root of 400. Now, square root of x cubed, can I simplify that? Yeah. Isn't this the same as saying 1, 2, 3? I need groups of 2. So this turns into x root x all over, what's the square root of 400? 20. Now the last thing you would do is you would see if your outside numbers can be simplified, but x over 20, no. So this is it. That's your final answer. That was not too bad, right? Let's look at our examples. I'm sure the examples are hard. Oh no. Is this the first example? Okay. All right. So I have the cube root of 6 over the cube root of 48. Oh, weird. Cube root of 6. Can't do that. So you know what? I'm looking at the 6. I'm looking at the 48. You know what? Just like you can separate it, you can join them together. Okay? So maybe it'll be more beneficial for us to join our fractions together and say 6 over 48. What is that? Can I simplify that fraction? Yeah, it's 1/8. Cube root of 1/8. Are we okay with that? All right. So then now split it up. Cube root of 1 over the cube root of 8. Yes. If you memorized your perfect cubes or are familiar with it, you would know cube root of 8 is 2. What's the cube root of 1? Good. So 1/2. Not bad, right? Isn't that pretty fun? Why does I want to say no? Hey, easy is fun, right? All right. I think this is when you give me the commentary. You don't have any comments on that last one? All right. So what about this one? Okay. Now, let's see. I have this whole fraction to the 1/3 power. What does that mean, to the 1/3 power? It's cube root. Okay, so you know what? I'm going to rewrite this as a cube root. Just because we're doing radicals. I realize you could do exponent
Yeah,
rule.
do that one first.
But we're gonna use the radicals here. Okay? So we have 343 x to the 5th over 27 y to the 9th. Yeah? Now, because I love to simplify before I actually start doing all this other stuff, 343 divided by 27, put it in your calculator. Can you simplify it? And then do math enter. Or if you are good with this, then just
simplify answer, 343.
Yeah. You can't simplify this fraction anymore. It's already simplified. Now you have 5x's on the top, 9y's on the bottom. Okay, you can't simplify those either. So now that just means I need to cube root everything. Okay? So I'm going to separate it now because I see some perfect cubes here. What is the cube root of 343? Thank you. What is the cube root of x to the 5th? Okay, it's 5/3, but let's simplify this radical. You have 1, 2, 3, 4, 5 x's. How many do you need in the group? 3. So 1x comes out, and then you have cube root. How many x's go back in?
X squared.
2, so x squared. Good. Now on the bottom, yup, cube root of 27 is 3. Now look at your y's. What is y 9 to the 9/3 power? Yeah. And so there you go. You're done. Well, and you can't simplify anything anymore, like the outside stuff, because 7 over 3 is already done. X, y cubed. Nope. All right. Are we okay with this? Yeah? Okay, good. Now, this one is my favorite, bless you. Rationalizing the denominators. Okay, you got to pay close attention to this one, okay? All right. Now, oh, you need me to go back. All right. Mm-hmm. What?
Never mind.
You got it?
Yeah, I wrote down the wrong number.
Uh-oh. Okay. So rationalizing the denominators. So the reason why we do this is because we don't want square roots in our denominator, okay? As a matter of fact, we don't really like having radicals in the denominator, and you may have like cube roots and all that stuff, but just not here, okay? We're only going to do square roots in the denominator, all right? So, so if you get like a cube root in the denominator, don't worry about trying to rationalize it, okay? So just with square roots. So if I have something like 1 divided by, or 1 over square root of x, then that needs to be changed. So we have 1 over square root of x, okay? Which is my problem. And then in order to get rid of this square root in our denominator, I need to multiply it by the square root of x over the square root of x. Okay? Which looks really weird, but isn't that just 1? The same thing on top, same thing on the bottom, right? Just multiplying it by 1. And then that equals, just multiply. Square root of x over, guys, radical multiplication rule. What do you need to do here? Inside times inside, which gives you x squared. But what's the square root of x squared? X. Isn't that weird? Did you get it, Isaiah? All right. Let it sink in. Are we okay in the back? Good. Cooper? All right, Gabby. All right. Okay, so let's try our examples. So this is example 2. Let me do example 1. I'm going to put example 1 over here, okay? 1 over the square root of 2. Let's rationalize that denominator, okay? So then what you're going to do is you're going to multiply it by the square root in your denominator, all right? On the top and on the bottom, okay? So then that equals square root of 2 over, what is this? Yeah, square root of 4, which equals 2. Are we okay with that? So then over here is example 2. 1 over 3 to the 1/2 power. Well, 3 to the 1/2 power is the same as saying what? Square root. Yeah, square root of 3. So this is really 1 over the square root of 3. Rationalize this denominator. Right? Thank you guys. See everyone writing? Good. Square root of 3 over square root of 3, which gives me square root of 3 over what? 3. Because this is square root of 9, which gives me 3. Does it feel a little bit better? It makes sense? Good. Yes, and you know, and you're doing that because if you multiply it by square root of 3 over square root of 3, you're multiplying it by 1, basically. It's not really changing a whole lot of it. All right. Are we okay with this? All right, let's try some examples. Okay, this guy. No. All right, so this one. Okay, I have a square root in the denominator, so no. I need to multiply it by what? Yes, square root of 2z over square root of 2z. And that gives me 4 times the square root of 2z over 2z. Yeah. You know, do you guys see the trend here when you're doing? Yeah. When you do you see the pattern? Square root of 2z times square root of 2z, radical just goes away and you get 2z, right? So if it was square root of x times the square root of x, is x. Yeah, right? And just to write it out, this would be 4z squared, which would be 2z. Yes? Although you're not done here. Why? Yes. Super annoying, right? We thought we were done. 4 over 2. So that's 2 root 2z over z. And that is your final answer. Okay? Fun lesson. That was easy? Good. Alright, let's try the last one. Okay, this one. Can you simplify 9 over 16? No, I mean just a fraction. Okay, so let's split this up because this is it's a fraction inside a square root, right? So maybe it'll work better if we do this. Yeah? Okay, so then what do we get? What is this? Yeah, square root of 9 is 3. Square root of x squared is x. over here, square root of 16 is 4, but wait a minute, I can't take out the y, right? So it's just square root y. Okay. Can't leave it that way because we don't like having a square root in our denominator, right? So we have 3x over 4 root y times what? Root y over root y. You can just multiply it by just whatever's inside your radical, just the radical part, okay? So then, sorry, I'm all over the place here, but I'm going to go to the left. 3x root y over 4 what?
Root 1 squared.
So what is the square root of y times the square root of y? Square root of y squared, which equals y. Just y. I can't simplify this anymore. Okay, so what happens is if you have square root of the same thing times the square root of, so if you're doing two square roots multiplying each other and they're the same thing, it's like that goes away and then you end up with just whatever was inside. All right, so wait, hold on. Everyone has homework? Okay, you have homework? Good. You're gonna get your mini quizzes back.
No.
This Friday is the last day for your unit 4 retake. Yeah? Next class, do you have another mini quiz? Yes. All right.